Hi, my name is David. Today we're going to do number 1249, minimum remove to make valid parentheses. So we have a function that takes in as a string, and inside of the string, we have to pay attention to the open and close parentheses. And we have to make them valid as in each opening has a closing. And it wants us to return a new string that has it fixed. We remove the minimum amount of parentheses needed to make it work. So for example, here, we see we have opening, opening, closing, closing, closing. So there's 3 closings. So we can remove any one of these closing ones to make it work. And this is one example, and this is another example. And there's another case where if we have a closing one before an opening one, we can remove this and it will work. So what we can do here is the idea is that we're going to have to loop through and use stack. So we're going to loop through here and then keep track of the opening parentheses. And when we see one, we add it to the stack. And we're actually going to add the index value of this position to the stack. And then when we see a closing one, we remove it. And then if there's any values left over in the stack, we can replace it as nothing. And we can delete it and we'll have a new string. And then there's this case where we're looping through and we see a closing parentheses, and we have nothing in the stack yet. So in this case, we will just remove this value and continue on with the process. And we can turn this into a string. So when we remove it, we just change the value from opening or closing parentheses to an empty string. And at the end, we can join it back together. So here's what I mean. So the first step is that we can convert S to S array. And next we create the stack. And now we're going to loop through the S array. And then inside of it, we can check if value is opening parentheses. And if it is, push the index to the stack. And now we want to check if the value is closing. So check if value is closing. And then we want to pop it off if we have something in the stack. So and stack.length is true. So we do that, and then we can just pop off the stack. Now we have the third case that check if value is closing and no stack length. Change the value to an empty string. Now we can loop through the stack. And inside of it, change the S array values of those indexes to an empty string. And lastly, we can just return the S array joined so it becomes a string again. So to put it in code, first we create convert it to an array. So const S array equals S dot split. Great. Now we create our stack, const stack equals, and now we loop through S array for let I equals 0, I is less than S array dot length, I plus plus, And now we check for the opening parentheses. So if S array index of I is equal to open parentheses, we push it to the stack. And we push the index of it. Else if S array index of I is equal to the closing one, and there's a length, stack dot length is true, truthy or greater than 0, we will pop the stack dot pop. And then also else if S array index of I is equal to closing one, and then we won't have to check the stack length first. If it has a stack length, it will hit this one first. Now we can just do S array. We're going to change the value to an empty string. I is equal to an empty string. Now we have to check for the stack, anything left in the stack to change. So for let j equal 0, j is less than stack dot length j plus plus. If no, there's no if, we just change it. So S array, and we have to get, so this stack will hold index value, so we have to do stack index of j, and we change it to an empty string. Now we just return S array dot join it all together. Great, we got it. So the time complexity. So we're looping through S for the split, and then we're looping through the S again, and then we can loop into the stack. At most, it's the S, so it's going to be, and then we're joining again. So it's multiple O of n's, where n is the length of S. So it reduces to just O of n, and then the space complexity. Since we're creating an array here, it's going to be the length of S again, so O of n, and then we'll create another stack that depending on O of n as well. So it's going to be O of n, and n is the length of S. And that's how you solve this problem. Thank you so much.